Dear learner, I welcome you all to the massive open online course on emerging technologies in renewable energy. I am Sanjay Agarwal, Professor and Pro Vice Chancellor of Chhattisgarh Swami Vivekanand Technical University, Bhilai. Dear learner, in the previous lecture we have discussed on the topic that is photovoltaic effect, and under this module we have discussed working in principle of the photovoltaic effect. Then we have discussed the type of the solar cell and how its efficiency is calculated. After that we discussed PV system for the power generation, and under this topic we discussed on grid, off grid generation from the PV system. So learner, in this particular session we are going to discuss flat plate collector, and after that we will discuss the principle of the solar water heater, then how efficient use of solar energy can be made, then what are the different energy losses associated with the flat plate collector, and after that we will discuss collector cum storage solar water heater and solar water heater based on the flat plate collector. And lastly we will discuss how the analysis can be done for the thermal performance of the solar water heater. So as you know, electricity is the high grade of energy and is obtained from burning fossil fuel at thermal power stations. The overall efficiency of generation, transmission, distribution and use is about 10%. Also, heating of water is like making use of low grade energy. It is really crime to use electricity for heating water when lot of solar energy is available for doing the same job by the device as known as solar water heater. One of the earliest application of solar energy is to heat water. You must have seen in the rural area that people keep bucket of the water in the sunshine for the heating, and it takes long time to heat the water in this way because of the heat losses and less absorption of the solar radiation. A flat plate collector is a heat exchanger that converts the radiant solar energy from the sun into heat energy using the well known effect that is called greenhouse effect. It collects or capture solar energy and uses that energy to heat water in the home for the bathing, washing and heating, and can even be used to heat outdoor swimming pool and hot tubs. For most residential and small commercial hot water application, the solar flat collector tends to be more cost effective due to their simple design, low cost and relatively easier installation compared to other form of hot water heating system. Also, solar flat collector are more than capable of delivering the necessary quantity of hot water at the required temperature. So broadly speaking, there are two types of solar collector. One is flat plate type and another one is concentrating type. A flat plate collector has the same area for the intercepting and for the absorbing solar radiation, whereas in concentrating collector sun's beam radiation is focused to a smaller receiving area, thereby increasing the amount of solar radiation. The solar water heater may be used for the domestic, commercial and industrial application. If you see for the domestic purpose, so what the temperature of water required is nearly, you can say, 50 to 55 degrees centigrade. So if you classify it as a application for the domestic purpose, so it is used in the flat, house and apartment. Now we talk about the commercial purpose. So commercial purpose means if you need the temperature of water or air, you can say from 60 to 80 degrees centigrade, so it comes under the category of the commercial purpose. And under the commercial purpose, it can be used in the hotel, lodge, hostels, hospital, dairy, etc. Now we talk about the industrial purpose. So if you need the temperature of the water is more than 80 degrees centigrade, then it comes under the category of the industrial application. That like example for preheating the boiled feed water, processing industries, dairy and for the dyeing purpose also. Now we will understand principle of the solar water heater. Solar water heater are classified in several ways. One of the widely used method is to be divided into two systems. One is active system and another one is passive system. So if we talk about the active system, so active solar system rely upon the moving mechanical parts in order to transport heat. The collector is usually an all copper tube and fin absorber enclosed with an insulated aluminum frame, or you can say box, which is covered with the glazing. Glazing, you can understand, glazing is just like a glass cover. The water is circulated through these solar panels. If we talk about the passive system on the other hand use the sun's energy to transport heat. Passive system can be divided into two types. One is thermosiphon and another one is collector storage. Passive solar system are popular because of the inherent simplicity and reliability. The storage tank is located on the roof and heating effect of sun causes warm water to circulate within it. So solar water heater are also classified based on their design, location, heat transfer mechanism. So if you classified on the basis of the design, location and heat transfer, so it can be classified as on the basis of the type of the collector, location of the collector, location of the storage tank, with and without pump, and what the method is used to transfer the heat. A solar water heater basically consists of the following. One is a collector to collect solar energy and second is a insulated tank to store the hot water. The solar collector could be flat plate collector or you can say evacuated tube collector. We will now discuss the solar water heater based on these collector types. For application where the temperature requirement are below 85 degrees centigrade, so following three types of the solar water heater may be used. One is collector cum storage solar water heater, second one is natural circulation type solar water heater, and third is forced circulation type of solar water heater. Now how the efficient of the solar energy can be used, just we have to understand this. The key to efficient use solar energy lies in the efficient mode of heat transfer in a solar energy collector. So basically there are three possible modes of the heat transfer. As you know, one is thermal conduction, second is a thermal convection, and third one is a thermal radiation. If you talk about the thermal conduction, so heat energy flows from high temperature to low temperature in a material. Wide variation in ability to conduct heat energy among different material is due to the density of free electrons in the material. Metals are required for efficient heat transfer because of their high thermal conductivity. Now we talk about the thermal convection. The liquid and gases transfer heat by convection. Fireplaces produce natural convection. Warm air rises and are replaced by the cold air. Most space heating system operates by convective heat transfer. Now if we talk about the thermal radiation, all materials absorb sunlight and heats up and then re-radiates that as long wavelength infrared radiation. Sandstone dwelling and walls absorb much sunlight during the day and then radiate that as a heat night. Now if we are talking about the efficiency of the water heater, so efficiency of the water heater basically depends upon the specific heat of the material, like what type of material are you going to use, like you are using the air or you are using the water, and its thermal conductivity. So basically specific heat measure of how much energy a substance can store. And if you talk about the thermal conductivity, the thermal conductivity measures of efficient of heat transfer. Now just you go through this table. So this table basically shows the specific heat and thermal conductivity of the different material like water, iron, glass and aluminum. And this specific heat and thermal conductivity you must know, because whenever you are going to design some solar water heater, so that means before the making or designing the parameter, just you have to calculate whether this particular solar water will be useful or not. So this parameter you must know. Now, energy losses in the flat plate collector. So when solar radiation falls on the surface of the solar collector, it is not possible for all solar photons to penetrate back collector's surface. Once of the collector becomes hotter than the environment, heat loss by the conduction, convection and radiation starts. The transmission and reflectance depends on the basically incident angle. The efficiency start decreasing if the collector becomes too hot, and the thermal radiation which goes up as the temperature to the fourth power dramatically increases. The overall effect is that the collector system has an efficiency which decreases with higher temperature. The following points guide the number of the glazing to be used. That means how will you decide that you will use the single glazing or double glazing. So basically single glass cover allows most sunlight but also most re-radiate infrared radiation. The single glass cover are the best suited for the low temperature difference. More than one glass cover admits fewer photons but inhibits radiative losses. The collector with more than one glass cover are the best suited at high temperature differences. So the orientation of the collector with respect to the sun is a crucial part of overall efficiency. Now we will discuss collector cum storage solar water heater. The collector cum storage type of solar water heater were designed, studied and developed and found very attractive for the domestic application. This type of solar water heater does not have any separate tank for water storage but serves the purpose for both collection and storage. The built-in storage and shallow pond water heater are widely used solar water heater of collector cum storage type. Here you can see the built-in storage type solar water heater. A schematic diagram of built-in storage solar water heater here is shown, just you can go through, and such type of collector are good in efficiency and easy to install and low in cost. Basically it mainly consists of the following component. One is a rectangular box covered with a glass wool insulation around the bottom and side walls, and second one is one or two glass cover at the top which is also called glazing. The system work on the greenhouse principle. When solar radiation is passed through the transparent cover or covers and impinges on the blackened absorber plate of high absorbability, it gets absorbed by the absorber. The glass cover allow the short wave solar radiation to enter. The thermal radiation, or you can say the long wave radiation, are not allowed to escape by the glazing. So the solar energy which enters inside the trapped and absorbed by the water. The underside of the absorber plate and the slide casing are well insulated to reduce conduction losses. In solar water heater, the water tubes are welded to the absorber plate or they can be an integral part of the plate. The water tubes are connected at both ends by the large headers. Now we will discuss function of the transparent cover. In solar energy collector, the transparent cover is used for the following purpose. First is to reduce convection losses from the absorber plate through the air layer between the absorber plate and the glass. Second purpose is, or you can say function is, to reduce radiation losses from the collector, because the spectral transmittivity of the glass is such that it is transparent to short wave radiation but nearly opaque to long wave thermal radiation emitted by interior of the collector. The third function is to further reduce the radiation convection losses when two or more transparent cover are used. Now we will discuss about the collector tilt. We will now discuss the orientation of the solar collector for receiving maximum solar radiation throughout the year. Flat plate collector are usually permanently fixed in position and require no tracking of the sun. Solar collector should be oriented directly toward the equator, facing south in the northern hemisphere and facing north in the southern hemisphere. The optimum tilt angle of the solar collector is equal to the latitude. For the winter season, the tilt angle should be approximately 10 to 15 degree more than the latitude. If we talk about the summer condition, the tilt angle should approximately 10 to 15 degree less than the latitude. The flat plate collector are useful in supplying thermal energy at moderate temperature. Up to the normal boiling point of water, that is 100 degrees centigrade. The major application of flat plate collector are in the domestic hot water and space heating, and to lesser degree in industrial processes. They can be employed to supply hot water in absorption refrigeration system for space cooling. Now we will discuss solar water heater based on flat plate collector. Solar water heater based on the flat plate collector works on the passive concept. Passive solar water heating system are mainly of two types. One is a thermosiphon system and another is integral collector storage system. So if we talk about the natural circulation type of solar water heater, the schematic diagram of solar water heater is shown in the diagram, which consists the following. Here you can see in the diagram also. One is an insulated outer metallic box. Second is metallic box is covered with the glass sheet called glazing. Then selectivity coated black metallic absorber sheet with the built-in channel, and next component is highly insulated water tank placed at height above the collector level. The solar radiation are absorbed by the absorber. The water in the tube get heated and then moves up because of decrease in the density and gets absorbed in the insulated tank. The fresh water enters the solar collector by the thermosiphon principle, which is also called natural flow. This process goes on till sunshine is available. The hot water in the tank can retain its heat for 2 to 3 days depending upon the insulation level of the tank. Nowadays, new polymer flat plate collector are available in the Europe, and these type of solar water heater are used for the domestic application and the places where electricity is not available. Passive solar systems have become widely acceptable because of their inherent simplicity and the reliability. The heating effect of sun causes warm water to circulate within the storage tank, and cold water flows directly to the tank and then flows to the conventional water heater. In case of the thermosiphon system, an insulated tank will prevent the loss of stored heat during the night. The both heater is the simplest kind of the solar heater, but the exposure of the storage unit to the night air can cause significant heat loss in the winter and produces the use of the kind of panel in the built in the mildest climate. Solar water heater not only save you money but also run for long time without you having to worry about it. There are many manufacturers of the solar water heater. Solar water heater designed and developed by Venus company is shown in this figure, and cross sectional view is also you can see in this particular diagram. Now we will focus on special feature of solar water heater. So special feature of solar water heater are: one is collector plate. If you talk about the collector plate, the special feature is it has high performance specifically coated collector plate to maximize the heat absorption from the solar radiation. Then water temperature up to 80 to 85 degrees centigrade can be realized in 3 to 4 hours of the bright sunshine. If we talk about the tank, so unique copper inner tank which has no corrosion, lifelong trouble free performance, thick insulation of glass wool to minimize the heat loss overnight, power coated aluminum body prevent the rusting and the corrosion, rugged and sturdy construction design help the withstand adverse weather condition, and it is safer than the electric heater. Now we will discuss typical flat plate collector. So here you can see in the diagram, a solar plate collector typically consists of a large heat absorbing plate, usually a large sheet of copper or aluminum, as they are both good conductors of the heat, which is painted black to absorb as much as solar radiation as possible for the maximum efficiency. The blackened heat absorbing surface has several parallel copper pipes or the tube called riser running lengthways across the plate, which contain the heat transfer fluid, typically water. These copper pipes are bonded, soldered or braced directly to the absorber plate to ensure maximum surface contact and heat transfer. Sunlight heats the absorbing surface, which increases in temperature. As the plate gets hotter, this heat is conducted through the riser and absorbed by the fluid flowing inside the copper pipe, which is then used by the household. The pipe and absorber plate are enclosed in an insulated metal or wooden box with a sheet of glazing material, either glass or plastic, or on the front to protect the enclosed absorber plate and create an insulating airspace. This glazing material does not absorb the sun's thermal energy to any significant extent, and therefore most of the incoming radiation is received by the blackened absorber. The air gap between the plate and glazing material traps this heat and preventing it from escaping the back into the atmosphere. As the absorber plate warms up, it transfers heat to the fluid within the collector, but it also loses heat to the surrounding. So to minimize the loss of heat, the bottom and sides of the flat plate collector are insulated with high temperature rigid foam or aluminum of foil insulation. Flat plate collector can heat the fluid inside using either direct or indirect sunlight from a wide range of different angle. They also function in diffuse light, which is dominant, or cloudy days, as it is the surrounding heat that is being absorbed and not the light, unlike the photovoltaic cells. How hot circulating water get will depend mostly on the time of the year, how the clear the sky are, and how the slowly the water flows through the collection pipe. Now we will discuss the direct and indirect solar thermal system. There are several ways to heat the water for use in the home. Solar water heating system that use the flat plate solar collector to capture the sun energy can be classed as either the direct or indirect system by the way in which they transfer the heat around the system. In order to heat your water successfully and use it during both the day and the night, you will need to have both a solar collector to capture the heat and transfer it to the water, and also the hot water tank to store this hot water for the use whenever it is needed. If we talk about the direct solar thermal system, a direct solar water heating system, also known as active open loop system, use a pump to circulate the water around the system. The cooler water is pumped directly from the home to the central water storage or immersion tank and passes through the solar collector for the heating. The hot water leaves the flat plate collector and returns back to the tank flowing in the continuous loop, and from there water is pumped back into the house as hot usable water. As low voltage 12 volt pump can be used which can be powered by the small photovoltaic cell or the electronic controller, making the system more green. It is a passive direct hot water system. The system does not use the pump or the control mechanism to transfer the heat created to the storage tank. Instead, passive systems are what are called open loop system, which is the natural force of the gravity to help circulate the water around the system. This type of system uses a solar flood collector combined with a horizontally mounted storage tank of some kind of located immediately above the collector. The water heated by the sun rises naturally using convection through the solar collector pipes and enter the storage tank situated above. As the heated water enters the storage tank above, the cooler water is forced out and flows down to the bottom of the collector aided by the gravity, as cold water is more dense than the hot water. This cycle of hot water rising and cooler water falling is known as the thermosiphon flow and continuously repeat unaided while the sun is shining. Now, and briefly we discuss about the thermosiphon hot water system. So just you go through this particular diagram. The thermosiphon system is the most common type of the solar heated water system on the market and most commercially available passive direct solar water system use this type of roof mounted flat plate collector and storage tank combination. However, care must be taken when insulating such type of system. The combined weight of the solar water collector, storage tank and water itself may be the much for the design of the supporting roof. When a passive solar water heater system are used for the bigger building than for the house, business or offices, there is often more than one storage tank for the heated water. So-called remote thermosiphon system work on the same principle as the previous passive direct thermosiphon system, except that the storage tank is located away within the roof place or void, dissipating the weight over the larger area and also protecting the storage tank from the cold weather and temperature. Now we will discuss site requirement for insulation of the solar water heater. So what type of site is required? One is unobstructed sunlight on the flat or the sloping roof. Then it must be the shadow free area. It must be close to the bathroom to avoid long piping so that the heat losses may be reduced, and water tank at a minimum of 2 to the 5 meter, or you can say 7 feet above the roof level, and solar panels should be faced toward the south so that the maximum solar radiation may be incident on the solar panel to get the maximum electrical output. Now we will discuss forced circulation type solar water heater. As the name implies, water in this type of solar water heater is pumped using the water pump, because these type of water heater are used where there is a requirement of large amount of hot water. The large number of solar collector is used in series as per the requirement. Now we will discuss thermal performance of the flat plate solar water collector. So thermal efficiency of the solar water heater is given by simple formula. So basically efficiency is what? Output upon input, because we are talking about the solar water heater. That means output is what? Useful heat energy gain in terms of the hot water, and input is what? Whatever the input energy is given in form of the solar radiation. So useful heat gain can be calculated by simple formula, that is Q is equal to mc delta T, and this Q is what? Basically it is a net output gain in terms of the heat, and this Q can be calculated by this formula, that is mc delta T, where what is m? M is nothing, it is a mass flow rate of water. It is generally measured in kilogram per second, and this C, or you can say Cp, is a specific heat of the water, and this delta T is basically difference in the temperature. If temperature of water at the outlet is denoted as a TO, and whatever the water is entering at the inlet is Ti. So, difference in the temperature is what? TO minus Ti. So, by putting all these parameter in this formula, Q is equal to mc delta T, you can easily calculate the efficiency of the solar water heater. Now, if you just driving the formula, just you have to remember this formula, Q is equal to Fr multiplied by the AC. AC is what? This AC is nothing, it is a area of the collector, just multiplied by the I is a solar intensity, multiplied by the tau alpha. Tau is a transmittivity and alpha is a absorptivity, and then UL multiplied by Ti minus Ta. What is this UL? UL is nothing, it is a collector overall heat loss coefficient, and it is measured in as watt per meter square. So, by just adjusting all these quantities, just you can calculate the efficiency of the formula. Efficiency can be written as Fr multiplied by tau alpha minus UL Ti minus Ta upon I. This Fr is what? This Fr is nothing, basically it is called heat removal factor. So, heat removal factor can be calculated as, it is the ratio of useful collected energy divided by useful collected energy if the absorber plate were at the inlet air temperature. So, the maximum value of this Fr can be unity. So, the value of tau alpha is always less than unity. So, you may now see the way how to increase the efficiency of the solar water heater. So, the collector efficiency can be increased by the following ways. Number one is by increasing the heat removal factor, or by reducing the heat loss coefficient, or by increasing the mass flow rate per unit area, and efficiency can also be increased by increasing the convective heat transfer coefficient between the water stream and the absorber plate. Now, we will discuss advantages of the solar water heater. So, there are number of advantage of solar water heater. Some of them are like payback period. So, if we are talking about the payback period, solar water heater have different payback period depending upon the fuel replaced. So, 2 to 3 year when the electricity is replaced, 3 to 4 year when furnace oil is replaced, and this payback period may be the 4 to 6 year when this coal is replaced. If we are talking about the fuel saving, so on average 100 liter capacity of the solar water heater can save about 1500 unit of electricity annually. So, you can say that because whatever the energy you are taking to heat the water, if you are heating this water from the solar water heater, so input energy is free, because whatever the energy you are getting, that is getting from the sun. Now, if we are talking about the environmental benefit, so solar water heater is green and renewable heating system. It does not release any harmful gases like carbon dioxide or the other pollutants. On average, 100 liter capacity of solar water heater can prevent 1.5 tons of the carbon dioxide annually. And another advantage is round the clock availability of the hot water. A solar water heater can provide hot water round the clock depending upon the size. And if we talk about the maintenance and the fuel cost, so solar water heater are maintenance free and there are no operating cost, and solar water heater has a long life, roughly 15 to 20 years. So, dear learner, in today's session we discussed principle of the solar water heater, and then how efficient use of solar energy can be made, and after that we discussed different energy losses associated with the flat plate collector, and we also discussed collector cum storage solar water heater and solar water heater based on the flat plate collector, and after that we have also discussed the thermal performance of the solar water heater, that means how you can calculate the efficiency of the solar water heater. So, as you know, the efficiency can be calculated if you are able to calculate the output of the solar water heater in terms of the heat, that is Q is equal to mc delta T. That means if you are getting the output of solar water heater, you must know the specific heat, you must know the mass flow rate and difference in the temperature, and input is what? Input is nothing, it is a basically solar radiation and multiplied by the area of this flat plate collector, which is can be calculated the intensity and area of the water collector. So, dear learner, in the next session we will discuss the solar air heater, and in the solar air heater we will also discuss the classification of the solar air heater and how this solar air heater work. Basically, it can again be classified as a natural type of solar air heater and forced circulation type of solar air heater, and we will also discuss what are the different advantages and disadvantages of this solar air heater.